Hello there and welcome back to the Sleepy Professor. I'm so glad you're here tonight. Get comfortable, let your shoulders drop, and take a slow breath. Tonight, we're going to drift together into the quiet mystery of intelligence. This beautiful, puzzling thing that sits at the very center of every thought you've ever had, every dream you've ever dreamed. You know, intelligence isn't just something humans possess. It's not just ours to claim. It's a presence that appears in the tallest forests, in the deepest oceans, in creatures with minds so different from ours that they almost seem alien. It appears even in the silent patterns that guide the universe itself. Intelligence is this strange, wonderful ability to imagine things that don't exist yet, to solve problems no one has seen before, to adapt when everything changes, and to create new possibilities from almost nothing at all. As you settle in tonight, I want you to imagine intelligence as a hidden current flowing through absolutely everything, shaping life in ways we hardly ever notice. In some ways it feels so familiar and comforting, like an old friend, and in other ways it feels so strange and mysterious that it completely changes how we see the world around us. It's one of science's greatest frontiers, you know, and we're only just beginning to uncover its secrets, to peek beneath the surface. Before we begin our journey, if you're enjoying these quiet explorations into the unknown, I'd love it if you'd consider liking this video, subscribing to the channel, or even just sharing a thought in the comments below. It truly helps other sleepy souls find their way here, one peaceful mind at a time. But for now, right now, all you need to do is rest. Let your eyes grow heavy. Allow your body to soften into whatever surface is holding you. And let your mind drift gently, gently into wonder. Let's begin. The dreams that built our minds. You know, there's this fascinating idea that intelligence might have emerged when our early ancestors began to dream more vividly. Really dream. Picture this with me for a moment. Long, long before there was writing, before there were cities or kingdoms or any of the structures we know today, sleep would wrap small bands of humans in complete darkness and vulnerability. They huddled together under the stars, surrounded by the sounds of the night. But inside those resting bodies, something magical was happening. The dreaming mind could roam absolutely freely, replaying events from the day and inventing entirely new scenes that had never actually happened in the waking world. Imagine a hunter, exhausted from the day, slipping into sleep. In his dream, he might relive a terrifying close call with a predator. But in the dream, everything plays out differently. The escape is smoother, cleaner. The path becomes clearer. His reactions are faster, more precise. Over many nights, hundreds of nights, these silent rehearsals in the theater of sleep could refine his instincts without any of the cost of real danger. Dreams do something remarkable. They blend faces together, merge places you've been with places you've never seen, and mix emotions into strange new combinations. It's like your mind becomes this experimental workshop where it can test out social situations that haven't happened yet, practice responses to future threats, and discover hidden opportunities. The individuals whose dream worlds offered better practice, richer imagination, more creative solutions, they may have moved through the waking world with more foresight and subtlety than others. Over countless generations, those slight advantages, those little edges, could have helped shape the complex storytelling intelligence that we humans carry with us today. Our ability to imagine, to plan, to wonder what if, it all might have started in dreams. The restless city inside your skull. Here's something that might amaze you. Your brain can actually rewrite its own wiring in just a single night of intense learning. Isn't that extraordinary? After a long day spent struggling with a difficult idea or wrestling with a new skill, your brain doesn't simply rest when you fall asleep. No, that would be too simple. As you drift off into sleep, billions upon billions of connections quietly reconfigure themselves. Some pathways grow stronger, others weaken and fade. Neurons that fired together repeatedly during the day, they're much more likely to build stronger links, forming routes that make future thinking smoother and faster and more effortless. There are these intricate chemical signals that adjust the sensitivity of synapses, those tiny gaps where one cell speaks to another in its quiet electrical language. In the deepest stages of sleep, your brain actually replays patterns of activity from your waking practice. It's like running internal drills without any conscious awareness at all. Even in a single night, just one night, this replay can carve entirely new paths through your neural landscape, turning clumsy attempts into more fluent performance by morning. You wake up and suddenly that piece of music feels easier to play. The pattern in the data becomes clearer, like fog lifting. A foreign phrase that felt awkward on your tongue the day before suddenly sounds more natural. Your skull, this beautiful bone structure, hides a restless city of cells inside it, tirelessly editing yesterday into a better version of tomorrow every single night. When animals outthink us. Now here's something that might humble us a little bit. Some animals actually outsmart humans in tests that were designed by humans themselves. Think about that for a moment. When scientists create puzzles to measure cleverness, they often expect, perhaps unconsciously, that human minds will sit comfortably at the top of the scale. We are the smart ones after all, right? But certain animals quietly overturn that assumption. They do it with such grace. In tasks that require spotting subtle probabilities, something humans often struggle with, pigeons choose the mathematically correct answer more consistently than many human volunteers. We humans get swayed by hunches, by gut feelings, by stories we tell ourselves. The pigeons just see the pattern. In visual memory challenges, some primates can recall the position of many symbols after just a fleeting glimpse. Their recall goes far beyond what typical adults can manage. These performances don't just show quick reflexes or good instincts. They reveal specialized strengths that were shaped by completely different evolutionary pressures, tuned to specific environments and survival needs that we can barely imagine. While we humans excel at language, at metaphor, at long-term planning and imagining futures that don't exist yet, other creatures absolutely shine in domains where precision matters most, where pattern recognition is everything, where sensory detail can mean the difference between life and death, the tests themselves. Crafted by human hands and human assumptions, become mirrors, and in those reflections, other species sometimes stand taller than we do. The decision before the decision. Here's something a little unsettling in the most fascinating way. A tiny portion of your brain predicts your decisions before you even become aware of them. Before you feel that clear moment of choice, that sense of "I've decided," a small network of neurons has already begun to lean toward one outcome. In regions of your brain that prepare movements and select actions, electrical activity gradually shifts, bit by bit, favoring one possibility while your conscious mind still feels completely undecided. This slow buildup of signal, unfolding over fractions of a second, reflects the accumulation of evidence, habits, and subtle preferences stored from so many past experiences you've had throughout your life. By carefully observing these patterns, researchers can often guess which option a person will select slightly before the person themselves reports having made a decision. It's like your conscious awareness arrives as a narrator who steps onto the stage just after the main plot twist has already happened. You're explaining a choice that was already in motion, already rolling forward. Now, this doesn't remove the meaning of intention or responsibility. Not at all, but it does suggest something profound. What we call a decision, that moment we point to and say, "I chose this," it's really just the visible crest of a much deeper wave of neural activity. A wave that's been rolling forward beneath the surface of awareness for longer than we realize. The art of ignoring. Here's a paradox that I find beautiful. Intelligence rises when the brain learns to ignore most of reality. Think about that for just a moment. Every single moment you're alive, your senses are delivering far more information than any mind could ever fully process. Light is flooding your eyes right now. Vibrations are pressing into your ears. Countless signals are traveling from your skin, your muscles, your internal organs. It's overwhelming when you really think about it. But intelligent behavior doesn't emerge from trying to absorb all of this detail. No, it emerges from discarding most of it. The brain quickly learns, through experience, which patterns actually matter and which ones can safely fade into the background. It filters out the steady hum of a fan without you even noticing, the constant pressure of clothing against your skin, the repetitive shapes in a familiar room that you've seen 1,000 times before. By compressing and simplifying the world around you, your brain frees up precious resources. resources it can use to track changes, to notice unexpected events, to spot meaningful relationships between things. The art of ignoring becomes this incredibly powerful cognitive tool. Minds that excel at this filtering, they can build cleaner internal models of the world. Models that focus on cause and consequence and opportunity, rather than drowning in raw sensation. And in that focused inner space, that's where complex reasoning can happen. That's where planning takes shape. That's where creativity can rise above all the noise. The genius of the octopus. Let me tell you about octopuses because they're absolutely extraordinary. Certain octopuses can solve puzzles they have never, ever seen before. In the dim water of an aquarium or in the shifting light of a coral reef, an octopus encounters a closed container. It smells faintly of food. Something delicious is inside, but no one has shown this creature how to open the device. No instruction manual, no demonstration. Using its flexible arms, lined with hundreds of sensitive suckers, it begins to explore every edge, every hinge, every surface of this strange object. And in some species, this exploration turns into remarkably fast problem-solving. The animal discovers how to twist a cap, slide a latch, or pull a plug. Its movements reveal something far more sophisticated than simple instinct. Here's what's truly amazing. Each arm can test different approaches independently, feeding information back to a nervous system that's distributed rather than centralized. Much of the octopus's neural tissue actually lies outside its main head region. It's as if parts of its body think locally, independently, while still contributing to a shared goal. When the container finally opens and the octopus reaches its reward, that moment represents something profound. It's where tactile memory, curiosity, and flexible control all converge. The result is a display of intelligence that developed along a path entirely, completely separate from the vertebrate mind. A completely different evolutionary journey leading to a completely different kind of genius. The beautiful accident of ideas. Your brain generates new ideas by mixing signals that were never, ever meant to touch. Inside your skull, networks that evolved for very different purposes are constantly interacting in ways that seem almost accidental. A region that once guided hand movements millions of years ago, now it participates in abstract reasoning about tools and concepts. Areas that track space and movement, they contribute to the way you navigate social situations. They help you understand numbers, hierarchies, relationships. When you relax and let your thoughts drift, not forcing anything, activity in distant regions of your brain begins to synchronize, linking emotional memories with factual knowledge, connecting sensory images with language, merging past experiences with imagined futures. Signals spill across boundaries that were supposed to keep them separate. They meet in association areas that act like busy crossroads in a city. There, unrelated fragments collide in patterns that normally never appear together. And from those collisions, new ideas can emerge, like sparks flying when stones strike at odd angles. A creative insight often feels sudden, doesn't it? Like it came from nowhere. But underneath that feeling of suddenness lies a slow, rich mixing of neural streams that were originally tuned for completely separate tasks. Your mind takes this accidental meeting of signals, this happy collision, and turns it into deliberate invention, into something new. The wisdom of trees. Let me share something that might change how you think about forests. Some trees use chemical messages so sophisticated they resemble what we might call primitive thought. In a quiet forest, imagine a single tree detecting the bite of an insect on one of its leaves. Within moments, just moments, chemical changes begin rippling through its tissues. It starts producing bitter compounds that make the foliage less appealing to the attacker. But here's where it gets really interesting. At the same time, airborne molecules drift outward from that tree, carrying information about the attack through the air. Neighboring trees of the same species can sense these signals, and they adjust their own defenses as if they've received a clear warning about an invisible danger approaching. Underground, there's even more happening. Roots form partnerships with fungal networks that transfer nutrients and signaling compounds across long distances. It's like an internet beneath the forest floor. Through these shared pathways, A tree that's struggling can actually receive resources from others that are thriving, or it can send out distress cues that alter the behavior of its companions. The timing of these exchanges, their specificity, the way they depend on context, it all creates patterns that look strikingly like problem solving. Without neurons, without a central brain, without anything we'd recognize as a mind. And yet, the forest still manages to gather information, spread it through the community, and respond in ways that benefit everyone. The whole living community working together. The futures you never see. Your brain is constantly simulating entire futures in the time it takes you to blink. Before you step off a curb, before you reach for a handhold, before you open your mouth to speak, internal models of possible outcomes flash into existence inside your head. In brain regions that handle memory and spatial navigation, patterns of activity sweep through imagined paths faster than your body could ever actually move. Your mind is rapidly trying out different sequences, predicting where obstacles might appear, anticipating how other people might respond to what you say or do. Most of this incredible work happens completely outside your awareness. It's compressed into moments so brief they feel instantaneous. You don't notice it happening at all. When you finally act, when you finally make that step or say those words, the choice you make carries the imprint of so many invisible rehearsals. The same machinery in your brain supports more abstract planning too. It allows you to picture career changes unfolding, relationships developing, creative projects taking shape over months or even years, all within a brief daydream. By running these compressed futures, your brain lets you harvest some of the benefits of experience without having to endure every possible risk. Each action you take carries echoes of countless unrealized possibilities. Possibilities that lived for only a heartbeat inside your head before vanishing. The beauty of imperfection. Human intelligence may actually depend on neurons that fire in beautifully imperfect patterns. Think about this. If each neuron in your brain responded to inputs in a rigid, repetitive way, perfectly predictable every single time, your mind would behave like a perfectly wound clock. Accurate, yes, but predictable, mechanical, limited. Instead, neural firing is full of subtle variability. Cells sometimes respond strongly to a signal, sometimes weakly, and sometimes they don't respond at all, even when the stimulus appears nearly identical to one they just responded to moments before. At first glance, this looks like noise, like an annoying flaw in what should be a delicate, precise system. But this irregularity, this beautiful messiness, it actually enlarges the space of possible responses. It allows your brain to represent shades of meaning rather than simple yes or no categories. Networks of such cells can explore many internal states while still remaining stable enough to function properly. In this flexible regime, small changes in experience can nudge patterns of activity toward entirely new configurations. Configurations that encode fresh insights you've never had before. Your mind gains the capacity to generalize, to handle ambiguity, to combine ideas in unprecedented ways. Intelligence grows not from perfect precision, but from structured imperfection. From this careful chaos woven through the firing of countless cells, billions of them, each contributing its own slightly unpredictable voice to the symphony. The genius in a grain of sand. Bees can recognize individual human faces with a brain smaller than a grain of sand. Let that sink in for just a moment. In a busy garden filled with shifting colors, moving petals, dancing shadows, a bee must quickly separate friend from foe, flower from distraction, opportunity from danger. Despite having a brain smaller than a grain of sand, this absolutely tiny creature can learn to distinguish individual human faces with surprising accuracy. Now, it doesn't see a face the way you and I do. It's not recognizing a person in the way we might. Instead, it breaks the image down into a pattern of shapes, edges, and contrasts. Then it stores the overall configuration as a kind of visual signature, a unique fingerprint. When the same person appears again, the bee can match that signature to its memory and respond accordingly. Maybe approaching if that person was associated with food, maybe avoiding them otherwise. This ability emerges from an incredibly efficient neural system that uses only a few thousand specialized cells to encode complex images. Instead of processing every single detail, which would be impossible, the bee focuses on the most informative features. It creates a lean and powerful method of recognition. This reveals something profound. Intelligence doesn't depend solely on size, on having a big brain. It can arise from elegant design, minimal waste, and the ability to extract meaning from the smallest fragments of perception. The story your brain tells you. Your brain predicts the world before it actually sees it, and it calls the mistakes reality. This is one of my favorite things to think about. In every waking moment, your brain is constructing a silent guess about what's going to happen next. Before a sound reaches your conscious awareness, before a shape becomes fully visible, internal models begin to anticipate the world around you. These predictions come from everything you've experienced, from memories, expectations, patterns learned over an entire lifetime. When the incoming sensory information finally arrives, when reality checks in, your brain compares it to its own forecast, and then it blends the two together until they match closely enough to feel seamless. Most of the time, this process creates a smooth and efficient experience. It lets you move through life without pausing to consciously interpret every flicker of light or shift in sound. You'd never get anything done if you had to process everything from scratch. But here's the thing, the guesses aren't always correct. The brain fills in missing details. It invents edges that aren't really there. It smooths over contradictions that might otherwise feel jarring or confusing. This delicate merging of expectation and perception, it shapes what you believe to be real. Your sense of the world isn't a raw recording. It's not like a video camera capturing objective truth. It's a refined story, built from constant predictions. A story your brain is telling you every single moment. The language of dolphins. Dolphins invent new whistles to name ideas they have never encountered before. Within the shimmering blue corridors of the ocean, dolphins communicate through whistles that curve and ripple like underwater melodies. These sounds aren't simple signals, like alarms or basic calls. They have structure, rhythm, variation that reflects an astonishing level of flexibility and sophistication. Dolphins can improvise entirely new whistles when they're faced with new situations. They create custom acoustic shapes that stand for unfamiliar objects, unique individuals, novel experiences that their species has never encountered before. In social groups, these invented sounds spread. Companions learn to interpret them. Each whistle becomes a bridge between thought and expression, allowing these animals to share information with remarkable nuance. The ability to generate symbolic sounds, to create new words essentially, emerges from a brain that evolved for cooperation, for hunting coordination, for complex social bonds. Dolphins must understand shifting dynamics within their pods. They need to track relationships between individuals. They respond to subtle cues in real time, navigating a social world that's just as complex as ours in many ways. Their expanding vocal repertoire acts as a cognitive toolkit. It allows them to form new associations whenever the world presents something unexpected, something they need to talk about. The power of being wrong. The mind actually learns faster when it completely misunderstands something first. There's a paradox at the heart of deep learning that I find beautiful. When your mind forms an incorrect assumption, when you get something totally wrong, it creates tension. Tension between your expectation and the evidence in front of you. And that tension becomes fuel for rapid improvement. A misunderstanding exposes the boundaries of your existing knowledge. It forces your brain to reorganize its internal models. Neurons that once fired confidently in one pattern must now shift, must adapt to accommodate this new information that contradicts everything they thought they knew. When the correction finally comes, when you realize, oh, I was completely wrong about that, it produces a sharper, more resilient understanding than if you'd simply absorbed the idea without any friction. This process appears everywhere. In children who struggle with a concept before suddenly mastering it. In adults who confront a mistaken belief they've held for years. Even in artificial systems that refine their predictions through repeated error. The initial confusion, that uncomfortable feeling of being wrong, It opens a cognitive space where new connections can form more freely. Your mind becomes more attentive, more flexible, more capable of forming insights that would never emerge without the spark of an early mistake. Being wrong isn't failure. It's often the first step toward truly understanding something. The raven's mind. Ravens can plan several moves ahead without ever practicing the task before. High on a windswept branch, a raven eyes a distant reward, something it wants. To reach it, the bird must perform a sequence of actions it has never executed before. There's no trial run, no practice, no one to show it the way. Without any of that, the bird evaluates the objects available to it, and it selects the tool that will allow the later steps to succeed. This ability reflects something extraordinary happening inside that small head, an inner simulation, a process where the raven mentally rehearses events before acting on them. Rather than relying on instinct alone, the way most birds do, it imagines how each object will behave, how obstacles can be overcome, how its movements will interact with the environment. Such foresight requires an understanding of causality and physical principles that go far, far beyond simple learning or conditioning. It reveals a mind capable of holding multiple possibilities at once, discarding the ones that lead nowhere, choosing the one path that opens toward a solution. In this quiet moment of planning, invisible to everyone watching, the raven demonstrates a level of reasoning that rivals much, much larger brains, including ours. The beautiful chaos we keep. Human creativity may actually come from neural noise that other species filter out. Inside your brain, signals don't flow with perfect order. Mixed within the purposeful firing of neurons is this layer of irregular activity that seems random at first glance. It looks like static, like interference. Many species suppress this internal noise to achieve precision and efficiency, a cleaner signal. But humans, we appear to preserve a portion of it. We keep some of that chaos, and this gentle chaos creates opportunities for unlikely connections to form. It lets ideas that normally stay in separate categories drift close enough to combine in unexpected ways. A stray memory may collide with a sensory impression. A half-formed image may merge with a mathematical concept. These encounters generate new possibilities, often without any conscious effort on your part. When your attention relaxes, when you stop forcing your thoughts in one direction, the noise actually grows louder. It allows your mind to wander through a wider landscape of thoughts. Over time, structured patterns emerge from that wandering, patterns that become metaphors, inventions, stories, imaginative leaps that take you somewhere completely new. Creativity becomes the art of shaping this controlled turbulence into something meaningful, into something beautiful. The comfort of giants. Elephants comfort distressed herd mates with behaviors that really do resemble empathy. In a savanna shimmering with heat, an elephant senses agitation in a companion. Maybe it's fear, maybe grief, maybe just uncertainty. Without hesitation, the elephant approaches with deliberate calm. The touch of a trunk across the face or shoulder carries a soothing pressure. Gentle, purposeful, a soft rumble vibrates through the air, a sound tuned specifically to reassurance. Other elephants may gather around, offering quiet presence rather than forceful action, just being there. These responses arise from an understanding of emotional states within the group. Elephants track the mood of their herd. They remember past events that shaped each relationship. They know each other's histories. When one individual suffers fear, grief, or uncertainty, the others react with comfort that seems to emerge from shared feeling rather than simple imitation. This emotional intelligence supports the cohesion of their social structure. It allows families to endure hardship together, to protect vulnerable members. Their comfort behaviors demonstrate something profound. The roots of empathy can grow in minds that evolved far, far from human experience, carried by memory, sensitivity, and these deep relational bonds. Patterns no human imagined. Artificial intelligence models reveal patterns in nature that no human had ever imagined before. Modern learning systems can sift through intricate data that spans entire oceans, complex climates, whole ecosystems. While they don't think in a human sense, don't have consciousness or awareness, their ability to detect patterns creates entirely new windows into the natural world. When given satellite images, they uncover hidden rhythms in the movements of forests, in ocean currents, in animal populations that migrate across continents. When trained on astronomical measurements, they reveal relationships between distant stars and swirling clouds of cosmic dust that had eluded researchers for decades. These discoveries arise not from intuition or hunches, but from an unbiased search through vast spaces of possibility. By highlighting connections too subtle or too complex for a human mind to notice on its own, these models expand our understanding of how life and the universe are organized, how everything fits together. Their predictions become hypotheses that scientists can explore, grounding imagination in fresh evidence. In this partnership, human insight and computational analysis weave together entirely new stories about nature, stories we couldn't have told on our own. The logic of parrots. Parrots can understand abstract rules that even children struggle with. In the presence of colored shapes, objects of different sizes, patterns arranged in deliberate sequences, some parrots show an ability to identify rules that aren't tied to specific items. They can tell when two things match in a certain property, even when the specific examples change completely from one trial to the next. This reveals a grasp of relationships rather than mere memorization. When you ask them to apply a familiar rule to an entirely new set of objects, they can extend their reasoning without hesitation, without needing to be retaught. Their understanding emerges from a combination of social cognition, problem-solving ability, and a natural curiosity that drives them to manipulate objects and explore cause and effect. These same traits support their complex communication and the deep bonds they form with flock members. As they navigate these rich social landscapes, their minds develop structures capable of handling subtle ideas. What looks simple on the surface, a bird identifying matching shapes, actually reflects a sophisticated internal logic, a kind of abstract thinking. The memory that changes. Your brain stores memories by rewriting them in new forms every single time you recall them. This might be unsettling to think about. A memory is not a preserved photograph. It's not filed away in a drawer somewhere, unchanged. Each time you reach for a memory, the very act of retrieval changes its structure. Your brain reconstructs the experience from fragments scattered across many regions. It stitches together sensory impressions, emotional context, and meaning into a single coherent whole. But during this reconstruction, the memory becomes open to alteration. New details blend with old ones. Interpretations shift. The narrative takes on the shape of who you are in that particular moment. Once returned to storage, the memory carries these subtle revisions. This process allows memories to remain flexible, adapting to new understanding and new circumstances as your life changes. But it also means something profound. The past is partially created by the present. Every time you remember something, you're recreating it just a little bit differently. Through this dynamic rewriting, your brain maintains a library that stays relevant to the challenges of your current life, rather than freezing experiences in rigid form. Your past is alive, always changing. The self-editing squid. Squid neurons use exotic biochemistry that lets them edit their own genetic messages. In the dim water of the open ocean, squid rely on a nervous system built for rapid action, for shifting color displays, for sudden bursts of movement that can mean the difference between life and death. The neurons use an unusual biochemical strategy that allows them to rewrite portions of their RNA. These are the molecules that act as working copies of genetic instructions. Instead of relying solely on the fixed information encoded in DNA, the way most creatures do, squid can actually adjust these RNA sequences to fine-tune how their proteins behave. This helps them respond to changing temperatures, shifting currents, complex environmental pressures. Editing RNA on the fly gives them an adaptive flexibility that most animals simply lack. By altering the messages inside their cells moment by moment, they can modify how electrical signals travel along their giant axons. they maintain precise control over their fast-moving bodies. This remarkable ability reveals a form of molecular intelligence that operates beneath any conscious awareness, a cellular system that adapts minute by minute to the fluid world around them. Music that builds the mind. Music can actually restructure thought patterns in ways that increase spatial reasoning. When musical tones rise and fall in carefully arranged sequences, your brain forms patterns of expectation. Activity synchronizes across regions involved in timing, planning, and prediction. Listening to music can guide your neural rhythms into more orderly states that encourage clearer, more coherent thought. Over time, these rhythmic patterns influence how your brain processes relationships in space, rotations, distances, geometric transformations. Practicing a musical instrument deepens this effect dramatically. It trains fine motor control, auditory discrimination, and working memory all at the same time. As these systems strengthen together, they knit together more efficiently. Your mind becomes better at forming clearer mental maps, at tracking complex spatial structures with greater ease. This influence extends far beyond the music itself. The structured flow of melody and harmony encourages your brain to explore new connections. It supports reasoning in fields like mathematics and navigation. Music becomes more than just sound. It becomes a quiet architect of cognition, reshaping how you think. Plants that see tomorrow. Certain plants anticipate light cycles and change their growth before dawn even arrives. Long before the sun rises, hours before, certain plants begin adjusting their orientation, their metabolism, their internal chemistry. These shifts occur even in controlled environments where the timing of external light remains constant. The behavior emerges from internal clocks built into their cells, clocks that track the passage of time through cycles of gene activation and suppression, creating rhythms that align with the turning of our planet. As dawn approaches, plants activate processes that prepare their leaves for photosynthesis. They adjust the opening of tiny pores. They redistribute sugars. They alter growth hormones so they can gather energy more efficiently when the first light finally appears. This anticipation helps them survive in environments where every moment of sunlight matters desperately. The precision of these internal rhythms reveals a quiet sophistication. Without nerves, without brains, without anything we recognize as intelligence, plants still sense patterns that extend far beyond immediate conditions. They remember the rhythm of days and seasons. The universe in your head. Your brain creates entire internal universes to test ideas before you speak them. Within the folds of your cortex, networks spring to life whenever you consider possibilities. As you prepare to express a thought, your brain generates internal simulations that play out imagined consequences. These mental spaces contain fragments of memory, sensory impressions, abstract concepts, all arranged into miniature worlds where ideas can be tested without any risk. When you're exploring a problem, your mind activates these internal landscapes. It lets possibilities rise and dissolve before any words form on your lips. Each mental universe is shaped by your unique experience, your emotions, your accumulated knowledge, yet it remains flexible enough to support entirely new combinations. In these quiet rehearsals that you're never aware of, your brain evaluates meaning, it adjusts phrasing, it settles on the version of the idea that best reflects your intention. Much of this process happens beneath awareness, invisible even to you. It gives the impression that thoughts emerge fully formed, but in truth, each idea is the result of countless unseen trials, little experiments running constantly. Understanding nothing. Crows understand the concept of zero as a meaningful quantity of nothing. In controlled experiments, crows can distinguish between symbols representing different quantities: 1 item, 2 items, 3 items, and remarkably, they can distinguish the symbol that stands for none at all. They treat this absence of quantity as a real value, placing it correctly on a mental number line. When shown varying amounts of objects, they respond differently to the case where nothing is present. This demonstrates an understanding that zero isn't simply the absence of something familiar. It's a distinct concept with its own place in a sequence. This insight requires a sophisticated mental framework that goes far beyond simple counting. It reflects the ability to generalize rules about order and magnitude. In the wild, such reasoning may help them evaluate risk, track resources, or interpret subtle changes in their environment. Their grasp of zero suggests that abstract reasoning, the kind we think of as particularly human, can emerge in minds shaped by evolutionary paths completely different from our own. The mind of the colony. Ant colonies act like distributed minds that solve problems no single ant could ever comprehend. Within a colony, thousands upon thousands of ants follow simple rules. Rules based on pheromone cues, local interactions, shared tasks. Each ant is relatively simple, limited in what it knows and can do. Yet when these individual behaviors combine, when they work together, the colony displays coordinated strategies that appear far more intelligent than any single ant could be. They regulate temperature inside their nests with precision by adjusting airflow through complex tunnel systems. They find efficient foraging routes by allowing the most successful paths to gain stronger chemical signals. They defend against invaders using collective maneuvers that shift dynamically based on the size and position of the threat. This emergent intelligence arises from distributed processing where no leader directs the group. No one ant is in charge. Instead, information flows through continuous movement, chemical exchange, and shared labor. The colony becomes a living network capable of flexible problem solving, adapting to challenges that would completely overwhelm isolated individuals. It's a different kind of mind altogether. The stories that made us smart. There's this quiet, almost ancient idea that human intelligence didn't simply appear like a spark in the dark. It unfolded gradually, like a long breath, growing softly around the glow of shared stories. Picture the world before writing, before symbols carved into stone, before anything could be saved except through memory. Our ancestors gathered beneath skies so wide they must have felt endless, skies full of drifting stars that looked like distant fires of their own. And around the warm circle of their earthly fire, the one place of light in a vast darkness, they spoke. The fire hummed, cracked, whispered. Sparks drifted upward like tiny spirits rising into the night. And in those shifting shadows, those amber echoes on skin and earth, people began weaving the earliest threads of narrative. The first stories were not written. They were breathed, shared, carried in voices shaped by wind and smoke and the hope of being understood. Imagine them there for a moment. Someone returns from a long walk, their feet dusty, their breath steadying as they begin to describe the shadow they saw moving between the trees. Was it danger? Was it opportunity? Another person lifts their chin and speaks of a stream hidden behind tall grass, one with cold water and bright fish darting like little slivers of silver. Another voice rises, soft and thoughtful, telling of a moment of trust or conflict or unexpected kindness from a neighboring group. Every story held something important, a warning that might save a life, a lesson meant to guide, a memory carried forward so it would not be lost, a possibility that opened the mind to new choices. These shared narratives were not simply a way to pass the time. They were survival tools, sharpened through generations. They allowed small communities to gather knowledge far beyond what any single person could ever witness alone. A young member of the group could sit behind the firelight, eyes wide, and learn about a cliff they had never climbed or a valley they had never entered. They could feel the presence of danger without ever being harmed by it. They could avoid mistakes they'd never committed. They could prepare for events they might never experience firsthand. Stories became bridges between minds, delicate yet incredibly strong. They connected the experiences of one person to the understanding of another. Through them, people stepped into moments they'd never lived, standing in shoes they'd never worn, feeling emotions they'd never encountered in their own lives. And as the generations drifted forward, slowly, quietly, hundreds upon hundreds of them, this constant exchange of stories shaped our species. It guided the architecture of our thoughts. It expanded the mental landscapes we now take for granted. Minds that could remember more detail, describe events with clarity, imagine possibilities beyond the present moment, or feel empathy for the heroes and sufferers in these tales. Those minds had an advantage. They could navigate social worlds that grew richer and more layered. They could plan further into the future. They could coordinate hunts, resolve tensions, form alliances, and teach children in ways that sustained whole communities. Storytelling didn't just encourage intelligence. It intertwined with it like roots growing around stone. Over time, it became a kind of structural support, a scaffolding that helped the human mind climb toward deeper understanding. The ability to turn events into meaning, to weave raw experience into a narrative arc, became part of who we are. To make sense of our lives through stories is one of the oldest traits we still carry. The songs of whales. And perhaps, just perhaps, something like storytelling passed not by firelight, but through the slow singing of the waves. Because when whales communicate, they do more than exchange information. They reach across distance with intention. Their voices carry history, tradition, and something that feels almost like culture. A calf learns the melodies of its pod the same way a child learns lullabies, through repetition, comfort, and closeness. These songs drift through generations, evolving slowly. Like ancient poems rewritten by time itself. Scientists have discovered that entire populations of whales sometimes change their songs at once, as if agreeing collectively to adopt a new chapter in their acoustic language. Imagine that, an ocean-wide shift in melody. A cultural wave rolling through thousands of miles of water, touching every member of the group. It's as though the sea itself becomes a library, each current carrying the updated verses of some enormous shared narrative. And when whales migrate, across hemispheres, across seasons, they bring those stories with them. They carry songs from warm shallows to icy depths, from equatorial blue to polar green. Along the way, they may encounter other pods, other dialects. Sometimes they blend, absorbing unfamiliar notes, merging old melodies with new ones. These interactions suggest not only intelligence, but openness, a willingness to learn, to adapt, to change. There is something profoundly gentle about it, something patient, something ancient. Their communication stretches across a world we can barely imagine, a world where sound travels farther than sight and meaning lingers long after the speaker has moved on. A world where a single voice can be heard by another whale hours later, continents away. If you listen closely, not with ears but with imagination, you can almost feel the ocean humming. A low, resonant chorus rising and fading, weaving itself through underwater mountains and drifting forests of kelp. A language shaped by pressure and darkness and the slow pulse of the tides. A language older than cities, older than agriculture, older than the first stories told around glowing fires. In those vast blue chambers, whales speak in ways that remind us of something we often forget. Intelligence is not ours alone. Communication, memory, shared experience. These are not exclusive to human minds. They ripple through other species, through other worlds, through lives lived very differently from our own. And so, when we think of storytelling, of the ancient human tendency to wrap meaning in narrative, we might consider that we are not entirely unique. Somewhere beneath the surface, drifting through the deep, enormous beings with gentle hearts and powerful voices may be telling their own stories too. Long, slow epics carried through the water, shaped by distance and time, echoing through the blue silence with a kind of grace we are only beginning to understand. Their songs rise, they fall, they travel, they evolve. And the ocean listens. And maybe in some quiet, mysterious way, so do we. The gentle architecture of thought. Now let's come back to something quieter, something closer. Let yourself settle for a moment, get comfortable. There is no hurry at all. Just breathe and listen as we drift through some gentle landscapes of the mind. Inside your brain, there are populations of gidding cells, almost like caretakers of your inner world. Without them, thinking would become stiff, inflexible, almost brittle. But these cells are always present, like subtle gardeners tending the electrical activity of your thoughts. They help creativity unfold. They help flexibility expand. They enrich everything without drawing attention to themselves. You rarely notice their work, yet they shape the texture of your mind every moment of your life. Now picture something curious. Some fish, just small shimmering creatures drifting through clear water, are capable of recognizing themselves in mirrors. It's astonishing when you think about it. When they glide past a reflective surface, they don't mistake the image for another fish. They pause, they observe, they understand. If someone marks their body with a visible spot, something they can only see in the mirror, they'll turn and twist, trying to remove it, because they recognize that the reflection isn't another creature, it's them. This awareness requires more than eyesight. It demands a sense of personal boundaries, of what is self and what is not, an inner model of identity. You can imagine the way they tilt their bodies, inspecting carefully, revisiting the mirror again and again. Their movements shift from instinct to intention. They reveal a depth of thought that gently nudges our assumptions about intelligence. In the quiet shimmer of a watery reflection, a tiny mind comes face to face with itself. And now drift with me to yet another corner of consciousness. Your mind is constantly searching for patterns. It's a storyteller by nature. When presented with scattered pieces of information, random shapes, unconnected ideas, it instinctively reaches for meaning. It stitches fragments together into coherent forms. It builds structure out of chaos. This tendency is ancient, born from the simple truth that recognizing patterns once meant survival. The rustle in the grass might be nothing. Or it might be something. So the mind learned to connect, interpret, imagine, and explain. In a way, we are always crafting stories. About the world, about others, about ourselves. Narrative is one of the oldest tools we possess, one that has guided our species through darkness, across oceans, through danger, and toward understanding. And even now, in the quiet moments, the mind continues its gentle work of making sense of everything it touches. Early humans benefited from sensing structure in their environment even when that structure was faint, barely there. Over thousands of years, the brain became specialized for weaving elements into narratives that explain what might be happening around you. Sure, this can lead to false impressions sometimes, but it also fuels creativity, imagination, interpretation. When you see shapes in clouds drifting overhead, or find rhythm in random sounds filtering through your window, or draw meaning from coincidences that probably mean nothing, you're witnessing this narrative instinct at work. It helps your mind compress complexity into forms that feel understandable, manageable. It provides emotional coherence and guides your decisions, even the small ones. Although it can mislead you, it also drives curiosity and exploration. Your mind makes sense of the unknown by shaping it into a story that feels whole and complete. Let's move underground for a moment, into the darkness. Bats use social learning to share new feeding strategies across entire colonies. Within dark roosts and under moonlit skies, bats pass knowledge from one individual to another through close contact and shared experience. When a single bat discovers a new food source or finds an unusual way to extract nourishment from a challenging fruit, others are watching. They observe, they mimic the behavior. Over time, sometimes just days or weeks, an entire colony can adopt this new method. A single innovation becomes a shared tradition. This transmission depends on trust, on memory, on the ability to map another creature's actions onto your own movements. Younger bats pay special attention to the experienced adults. They follow them during foraging flights through the night air, repeating behaviors until they master the technique completely. Through this process, colonies adapt to changing environments with remarkable agility. Feeding strategies become part of a cultural inheritance, not passed through genetics, but through living demonstration, through watching and learning and remembering. Here's something interesting about you. Human curiosity expands when your brain encounters something it cannot predict. When your mind meets a situation that doesn't match expectation, a spark of heightened attention ignites inside you. Neural circuits become more active, suddenly alert, absorbing detail with greater sensitivity than usual. This surge of interest encourages exploration. It allows unfamiliar information to flow into memory more deeply than routine events ever could. Curiosity grows in this gap between what you know and what feels just out of reach, just beyond your fingertips. It pushes your mind to investigate, to compare, to experiment, and to reorganize understanding in new ways. These moments often shape lifelong interests. They guide people toward fields of study or creative passions they might never have pursued otherwise. Your brain thrives on novelty because it expands the range of possible ideas, revealing new paths through the world you inhabit. Curiosity becomes both a compass and a fuel, pulling your mind forward whenever the horizon shifts. Now imagine something that seems impossible. Slime molds solve mazes through a form of memory stored in their shifting shape. Despite lacking neurons, no brain at all, slime molds navigate complex environments with surprising intelligence. When you place one in a maze with food positioned at the exit, the organism spreads through every available path like liquid thought. Over time, it withdraws from dead ends. It reinforces the route that leads to nourishment. This process resembles memory, but it's not stored in cells the way yours is. It's stored in the changing geometry of the organism itself. Each stretch and retreat leaves subtle chemical traces that influence future movement. As the slime mold reshapes its body, flowing and contracting, its shifting form records which paths are useful and which are not. The result is a dynamic map etched into living tissue. Through continuous growth and retraction, the organism learns and remembers without a brain. It reveals that intelligence can arise from the simplest materials when they're organized in the right way. Your brain builds maps of the world using rhythm, like an internal song that never stops playing. Deep within your brain, networks pulse with repeating patterns that act like a silent melody, guiding perception and movement. These rhythmic cycles help organize spatial information, allowing your mind to track locations, distances, and boundaries without conscious effort. As you walk through a room or move along a familiar road, these internal rhythms synchronize with sensory input. They create a stable map that persists even when vision is limited, even in darkness. They provide a scaffold for memory, helping you recall where objects lie, which paths you've taken, and how far you've traveled today. These internal songs shift subtly as you change pace, direction, or goal. They adjust the mental representation of space inside your mind. Without these continuous pulses, navigation would become disordered and unstable. The rhythm gives the world structure inside your mind, a quiet architecture you never see but always use. Out in the wild, large predators teach their young through lessons that resemble apprenticeships. In grasslands stretching for miles, in forests thick with shadow, and across icy tundra, young predators learn not through instinct alone, but through guided practice. Adults demonstrate stalking techniques, the art of chasing, the precise timing needed to bring down prey successfully. They allow juveniles to attempt difficult tasks while staying close enough to intervene if danger arises. Each lesson offers new challenges, gradually building skill and confidence over weeks and months. Young animals study every movement with intense focus, absorbing how to read wind direction, how to approach without making a sound, and how to coordinate within a group. These sessions continue long after the young can walk and hunt in basic ways. This shows that mastery requires more than instinct. It requires mentorship. Knowledge passes through generations as lived experience rather than fixed programming, giving each new generation a richer foundation for survival. Let's think about language for a moment. Human language may have emerged when our ancestors learned to manipulate symbols for fun, just for fun. Before words carried meaning the way they do now, early humans likely experimented with sounds, gestures, and marks simply because they found joy in play. These playful acts created patterns that companions began to recognize and repeat. Over time, gradually, certain sounds gained consistent associations with common objects or actions. As these associations solidified in their minds, groups developed shared symbolic systems rooted in joy, curiosity, and creative exploration. Play allowed individuals to test new forms of expression without fear of making errors. It encouraged imitation, variation, and elaboration. Gradually, these simple symbolic experiments grew into richer forms of communication. From casual mimicry emerged structure. From shared pleasure emerged understanding. Language may have begun as a form of imaginative play long before it became the powerful tool that carries thought across generations. Consider this: certain spiders plan hunting routes that require multiple sequential decisions. When these spiders explore complex terrain, They inspect branches, leaves, shadows, and angles long before making their move. Instead of relying on instinct alone, they pause. They study the environment carefully, evaluating which path will place them in the best position for an ambush. Their movements shift from quick exploration to deliberate planning as they test surfaces, backtrack, and reposition themselves with notable purpose. Once a route is chosen, they commit to it with steady precision, even if it requires several steps before reaching the right vantage point. Some individuals will inspect an area thoroughly, retreat to a hidden spot, and later return to follow a path they selected earlier. This reveals an inner process that stores temporary information about location, distance, and opportunity. Their ability to coordinate multiple moves without external cues suggests an unexpected depth of organization. In the quiet world of leaves and webs, these spiders make decisions that unfold like miniature strategic plans. Here's something about how you see the world. Your brain understands motion before it recognizes the objects that are moving. As soon as something shifts in your environment, even slightly, specialized pathways in your visual system react to the change even before your brain identifies what's actually moving. This rapid sensitivity to motion comes from ancient neural circuits that evolved to detect predators and prey and other crucial events that could mean life or death. These circuits respond to direction and speed with astonishing quickness, allowing your mind to prepare for action before conscious recognition forms in your awareness. Only after this first wave of activity does your brain piece together shape, texture, color, and identity. This separation gives you a powerful advantage. Motion sets the stage, drawing attention to areas that matter most, guiding your gaze and sharpening perception automatically. This early processing influences your decisions, your emotions, and your expectations. It shapes how you respond to the world moment by moment. The deep layers of your visual system reveal that understanding movement isn't a refinement of sight. It's one of sight's earliest and most fundamental purposes. Apes create tools in ways that reveal their ability to infer hidden mechanisms. When apes shape sticks, adjust branches, or modify stones, they often behave as though they understand the invisible forces that make these objects effective. They test weight carefully, length, flexibility. They discard tools that fail to match the demands of the task at hand. This shows they're not simply copying learned patterns from others. They're reasoning through the problem themselves. In experiments, they'll choose tools that can reach beyond their direct grasp, alter objects to improve leverage, or combine materials to create shapes they've never seen before in their lives. These actions suggest that apes can imagine how a tool will behave before using it. Their choices reveal an understanding that certain hidden properties, like strength or tension, influence results in predictable ways. This ability forms a link between animal cognition and early human invention. It shows that the foundations of technological thought run far deeper in evolutionary history than anyone once believed possible. Now let's talk about insight. Human insight often appears when your brain switches into what's called a metastable neural state. Inside your brain right now, countless networks are humming with their own rhythms. When an insight emerges suddenly, the system briefly enters a fluid condition where these rhythms loosen, reorganize, and reconnect in unusual ways. This state lies between order and chaos. It's not fully stable, yet not disorderly either. During this delicate moment, information that was stored in separate regions can suddenly interact, creating new relationships that your mind hadn't considered before, not even close. People often experience these moments as sudden clarity washing over them. A problem that felt impossible becomes simple in an instant. A connection that once seemed hidden becomes obvious. This shift doesn't result from direct effort or concentration. It comes from your brain allowing itself to move into a flexible arrangement where ideas can reorganize freely without constraint. Once the insight forms, the system settles again, holding the new understanding in a more stable pattern. Insight arises from your brain's ability to briefly relax its normal boundaries and explore new internal configurations you didn't know were possible. Birds with tiny brains can perform logic tasks once thought impossible without a cortex. Despite their small size, The brains of certain birds contain densely packed neurons arranged in highly efficient networks. These structures allow them to reason about relationships, understand cause and effect, and perform tasks that mirror logical decision-making. Experiments show that some birds can identify whether items match certain rules. They choose correct options from multiple alternatives. They even understand basic relational concepts that seem quite abstract. Their success doesn't come from mimicry alone. It emerges from internal processes that track patterns, test hypotheses, and evaluate outcomes intelligently. These birds solve problems using strategies that reflect structured reasoning. Even though their brains lack the layered cortex seen in mammals like you, this discovery challenges long-held assumptions about how intelligence is actually built. It shows that thinking doesn't depend on size at all, but on organization, density, and the way networks connect together. In the flutter of wings and the tilt of a small head, powerful cognition reveals itself quietly. Let's drift underwater for a moment. Some coral polyps share nutrients in patterns that resemble resource planning. On the surface, a coral colony appears simple, almost primitive, but deep within its living tissue lies a complex network of exchange that's anything but simple. When light, temperature, or nutrients shift in the surrounding water, individual polyps adjust how they store and release energy. Some transfer resources towards sections of the colony that require urgent support, such as areas recovering from damage or portions that receive less sunlight than others. Others temporarily reduce their own demands to stabilize the whole colony. These transfers follow patterns shaped by internal signals, environmental feedback, and interactions between countless polyps. Over time, the colony behaves like a system making choices about distribution, investing resources where the return will be greatest for survival. This coordinated sharing reveals a distributed intelligence built from simple units working in harmony together. It shows how life can plan without a central planner, using communication and cooperation to maintain balance in the shifting underwater world that never stops moving. Human genius often emerges from the ability to combine unrelated ideas. When your mind encounters two concepts that appear to have nothing in common, absolutely nothing, a unique cognitive process begins inside you. Instead of rejecting the mismatch, human intelligence often blends the ideas, forming new structures that didn't exist before anywhere in the world. This combination can generate inventions, stories, theories, or insights that feel astonishingly original. Genius thrives on these unexpected unions. Your brain searches for hidden links, allowing memories, emotions, and abstract thoughts to mix freely. This mixing doesn't follow a predictable formula. It grows from curiosity, flexibility, and a willingness to explore unfamiliar mental territory without fear. Many breakthroughs in science, art, and philosophy have emerged from this ability to cross boundaries that others thought were fixed. Genius isn't a single skill you either have or don't have. It's a way of navigating thought that welcomes the unusual and embraces the collision of different worlds. Sea lions learn rules of syntax that mirror basic principles of human grammar. During training tasks conducted over months, sea lions have demonstrated the ability to understand how elements in a sequence relate to each other. They can learn that certain symbols must appear before others, that some combinations create meaning while others produce nonsense, that relationships between elements remain consistent even when new symbols are introduced. This ability reveals an understanding of structure rather than simple memorization of correct answers. When given new arrangements they've never seen, they evaluate the order and respond correctly only when the pattern matches the rule they learned earlier. Such behavior shows sensitivity to syntax, a foundational principle in human language. Although sea lions don't speak the way you do, their ability to process structured relationships highlights a cognitive competence once believed to be uniquely human. Something only we could do. Their minds navigate patterns with an elegance that mirrors grammatical reasoning perfectly. Here's something that might surprise you. Your brain prunes connections to become smarter by becoming simpler. As your brain develops from childhood onward, it creates far more connections than it will eventually keep, far more than it needs. Over time, many of these connections are trimmed away, reducing complexity while strengthening efficiency at the same time. This pruning process allows signals to travel more cleanly through your brain. Thoughts form more precisely, responses sharpen and quicken. Instead of relying on sheer volume of connections, your brain refines itself by removing paths that add noise or confusion to the system. This simplification supports learning, memory, and reasoning in ways that seem counterintuitive. It helps your mind focus on what matters while discarding what slows it down unnecessarily. Pruning continues throughout your entire life, guided by experience, practice, and changing needs as you grow and age. Intelligence thrives not because your brain grows endlessly larger, but because it becomes an elegant network shaped by what each person encounters day after day. Some primates teach cultural traditions that persist across many generations. In several primate communities scattered across the world, individuals pass down behaviors that reflect shared culture rather than instinct alone. Elders demonstrate techniques for finding food, preparing materials, or resolving conflicts peacefully. Young members watch closely and practice until they master each tradition completely. These behaviors differ from one group to another, even when the groups live in similar environments with the same resources available. This shows that the knowledge is learned rather than inherited genetically. Over time, these traditions evolve gradually, gaining new variations or subtle refinements that mark different eras. They form collective identities that shape how groups behave and cooperate over decades. This cultural transmission reveals a level of intelligence grounded in community and memory together. It shows that cognition isn't only an individual trait locked inside one brain, but a shared resource carried across lifetimes through the stories and practices of an entire group. Human intelligence may grow when we confront ideas that contradict our beliefs. When a familiar viewpoint is challenged directly, your brain shifts into a heightened state of evaluation that strengthens cognitive flexibility. This encounter with contradiction disrupts automatic thinking and forces deeper examination of assumptions that often remain invisible to you. As your mind works to integrate conflicting information that doesn't fit, neural networks that usually operate separately begin to interact more vigorously than normal. These interactions create new pathways that expand how you understand the world around you. Over time, repeated exposure to ideas that push against your comfort zones encourages the development of more nuanced reasoning that sees shades of gray. Emotional regulation also improves because your mind learns to remain steady even when faced with perspectives that feel disorienting or uncomfortable. This process strengthens intellectual resilience and supports growth in fields requiring creativity, open-mindedness, and critical thought. Confronting contradiction doesn't weaken understanding the way it might seem. It enriches it by prompting your brain to refine and reorganize what it knows into something better. Ants use chemical communication networks to optimize foraging routes in real time. In a bustling colony beneath your feet, ants move across the ground, leaving trails of faint chemical signals that accumulate into a dynamic map of opportunity. Each ant follows portions of this map, adding new information as it travels along. When a rich food source is discovered by one scout, the concentration of chemical markers increases rapidly along that path. As more ants follow it in a line, the trail becomes stronger and more efficient with every journey. When the resource declines or disappears, fewer ants reinforce the route and the signal begins to fade naturally. This continuous updating creates a form of collective intelligence in which the colony adapts instantly to a changing environment. No single ant understands the entire map spread across the landscape. Instead, each individual responds to local cues right in front of them, contributing its movement to a living flow of information. This decentralized strategy allows the group to solve complex optimization problems with elegant simplicity. In the silent exchange of scent molecules, ants build shared knowledge that guides the entire colony towards success day after day. Your brain represents concepts as clouds of activity rather than precise locations you could point to. A concept in your mind isn't stored in a single place like a file in a cabinet. Instead, it exists as a shifting constellation of neural activity that changes depending on context, emotion, and sensory input in the moment. When you think about an idea, any idea, clusters of neurons in several regions activate at once. Each cluster adds a unique component to the whole. Some regions contribute sensory impressions. Others contribute emotional tone, memory associations, or abstract structure. Together, they form a cloud-like pattern that your brain can reshape as experiences accumulate over your lifetime. Because these clouds overlap and blend at their edges, concepts can influence one another and inspire new connections you've never made. This distributed form of representation allows remarkable flexibility in thinking. It explains how a familiar idea can feel entirely different in a new situation or context. It also reveals why creative thinking feels expansive, as if your mind is navigating vast landscapes rather than retrieving fixed entries from a mental archive that never changes. Otters pass down tool use techniques through memory and observation. Along coastal shorelines where waves lap gently, otters float on their backs with stones balanced on their chests. They strike shells with rhythmic precision over and over. Young otters watch these actions with intense focus, observing how adults select the right stone, position it comfortably, and apply just enough force to open stubborn shells. Eventually, when they're ready, the young begin to imitate these movements. They experiment with stones of different weights and textures. They adjust their grip. They learn to strike at effective angles that actually work. These lessons become part of family identity, as certain groups favor particular stones or develop distinct ways of cracking open different kinds of prey. Over generations, such practices evolve into long-lived traditions that define communities. This passing of knowledge demonstrates a cognitive capacity for cultural inheritance. The techniques survive not through instinct written in genes, but through shared memory and careful observation, revealing a level of learning that binds otter communities together across time. Human imagination works by blending memories into patterns that have never existed anywhere before. When a new idea forms in your mind, the mind gathers fragments from past experiences and arranges them into shapes that defy direct memory. A scent from early childhood may connect with a scene glimpsed on a distant journey years ago. An emotion from a conversation yesterday might combine with the image of a place only visited in dreams that never happened. These fragments merge to create possibilities that feel fresh and compelling and entirely new. This blending process relies on networks that bridge sensory memory, emotional learning, and abstract thought seamlessly. Imagination becomes a space where the past transforms into new patterns that never existed before in reality. It allows people to envision inventions, stories, solutions, and futures that haven't happened yet. By drawing on its deep reservoir of lived experience and reorganizing it through boundless creativity, your mind constructs entire worlds that live only in thought. Manta rays show signs of curiosity that resemble introspective awareness. As manta rays glide through warm ocean currents with effortless grace, they sometimes approach unfamiliar objects or reflective surfaces with an unusual degree of attentiveness. Instead of responding with fear or aggression like most creatures, they circle slowly, adjusting their angle and distance as though examining details intently with purpose. When encountering reflections in clear water, some individuals engage in movements that appear exploratory rather than territorial or defensive. Their gentle turns and pauses give the impression that they're studying their own appearance or testing how the reflection responds to their movements. In the open sea, they also investigate new shapes, lights, and textures with sustained interest that lasts minutes. This behavior suggests more than simple attraction to novelty. It hints at a deeper form of curiosity in which the animal explores not only the environment around it, but its own presence within that environment. The calm and deliberate nature of their actions reflects a quiet intelligence that remains largely mysterious to us. Your mind learns complex skills by running internal simulations over and over. Before performing a skill in the physical world, your mind often rehearses it internally without moving at all. These mental rehearsals activate many of the same neural circuits that support actual movement, allowing learning to occur even in complete stillness and rest. A musician may silently practice difficult passages while lying down motionless. An athlete may imagine a sequence of steps while resting between sessions. A speaker may run through words without moving the lips at all. Each rehearsal strengthens connections that guide timing, coordination, and precision in ways that feel almost magical. Over time, the simulated action becomes more refined and polished, preparing the body and mind for smooth execution when the real moment arrives and matters. This internal rehearsal is a powerful learning tool because it allows limitless repetition without fatigue or risk of injury. It transforms imagination into a form of silent practice that accelerates mastery of any skill you choose to develop. Social insects exhibit group memory stored in the movements of the entire colony. In colonies where thousands of insects interact constantly, memory doesn't reside in individuals the way yours does. It lives in the collective flow of behavior across everyone. When conditions change suddenly, the entire colony shifts its movement patterns in response together. If a threat appears anywhere, workers adjust their pace and direction, creating a recognizable pattern that persists long after the event has passed. During productive times of abundance, the rhythm of activity becomes faster and more synchronized, forming another distinct pattern you could observe. These collective motions serve as traces of experience that guide future responses when similar situations arise. The colony remembers not through personal recall in individual brains, but through coordinated action across thousands. Every movement reinforces or alters the shared pattern slightly, turning the entire colony into a living record of events. This distributed memory allows the group to navigate challenges with precision that no single insect could ever achieve alone in isolation. Creative insight often emerges when your brain temporarily reduces executive control. When the systems responsible for discipline and focused attention relax their grip, your mind gains access to a wider range of associations than usual. Ideas that normally remain separated in different mental compartments begin to drift toward one another, forming unexpected connections. This shift allows distant memories, subtle impressions, and imaginative fragments to merge in new ways. Creative insight arises when these elements align in a novel and meaningful way that feels right. People often experience such moments during restful activities like walking slowly, bathing, or drifting into sleep, when external demands fade completely. During these intervals, your brain explores without pressure or judgment, embracing possibilities that rigid focus would block entirely. Once the insight appears clearly, executive control returns naturally, stabilizing the new idea and making it useful. Creativity flourishes in this interplay between looseness and structure, where freedom opens the door and discipline shapes the result. Certain crabs navigate using celestial cues like tiny astronomers with shells. On coastal sands beneath open sky stretching forever, certain crabs orient themselves using patterns of light that filter from above. They detect the position of the sun throughout the day. They read the subtle polarization of sunlight reflected across the landscape around them. Even when clouds obscure the sky completely, they read faint gradients that reveal the hidden direction of daylight somehow. These cues allow them to travel long distances with reliable accuracy that seems impossible. As they scuttle across beaches and tidal zones between water and land, they adjust their path based on shifting celestial information, navigating with precision that seems astonishing for such small creatures with simple nervous systems. Their reliance on sky-based guidance shows a remarkable ability to process complex environmental signals that most animals ignore. In their tiny bodies lives a form of natural astronomy that allows them to move confidently through a world shaped by tides, shadows, and the slow sweep of the heavens above. Human learning strengthens when surprised by information that violates expectation completely. When something happens that doesn't fit what your mind predicted would happen, a quiet alarm rings through your nervous system instantly. Circuits involved in attention, error detection, and memory light up together all at once. This moment of surprise pushes your brain to stop gliding along old habits and instead examine the new event in sharper detail than usual. Neurochemicals that support learning rise throughout your brain, marking the experience as important and worth remembering. Your mind begins to compare the unexpected fact with older knowledge carefully, searching for a way to fit it into a larger pattern. Or when needed, to reshape the pattern itself into something new. Lessons linked to surprise are stored more deeply and recalled more easily because they carry the imprint of emotional and cognitive urgency that demands attention. Over time, a life filled with gentle repeated surprises builds a mind that updates itself more readily, that stays flexible and adaptive, and that remains open to correction instead of clinging to comforting illusions that feel safe but aren't true. Robots using self-organized learning develop strategies humans never considered possible. In complex environments where outcomes depend on many interacting factors, self-organized learning systems explore possibilities in ways human designers could not plan in advance. Engineers set basic rules and goals, then allow the machines to adjust their own internal parameters through trial, error, and continuous feedback. Given enough time and variation, these systems discover approaches that appear alien to human intuition at first, yet perform remarkably well in practice. A robot might learn to move in a strange gait that looks inefficient but conserves energy over long distances in ways engineers never imagined. Or it might rearrange its own sequence of actions to exploit tiny details in its surroundings that humans wouldn't notice. Researchers studying these solutions often find that the strategies obey principles that were invisible before the machine uncovered them through exploration. In this way, self-organized learning turns robots into collaborators in discovery, expanding the space of possible behaviors beyond what any single human mind could imagine alone. Your brain encodes spatial knowledge through firing patterns that act as internal coordinates you can't see. As you move through a room right now, walk along a familiar path, or turn a corner in a city, you know well specific groups of neurons fire in patterns that map where you are and how you're oriented in space. Some cells become active when you occupy a particular location in the world. Others respond to the direction you're facing or the boundaries around you that define the space. Together, they form an internal grid that tracks position within the environment constantly. This grid doesn't use physical measurements like a drawn map with numbers and lines. It uses rhythms and sequences of activity that shift as you move, maintaining a stable sense of space inside a constantly changing world that never stops. When you later recall a route you've taken, these patterns replay in altered form, guiding your memory of where to turn and how far to go next. Spatial knowledge lives not as a picture you can see, but as a living choreography of electrical pulses that traces the world within your brain. Primates use social strategies that resemble elementary political reasoning you'd recognize. In groups of monkeys and apes living together, individuals do more than react to dominance and submission in simple ways. They track alliances over time. They trade favors with specific individuals. They manage reputation in ways that look strikingly like simple politics unfolding. A primate may groom one partner carefully to secure support in a future conflict that hasn't happened yet, or it may choose to back a particular ally at a critical moment, strengthening a bond that will later provide protection when needed. Some individuals reconcile after fights with gestures that restore trust and repair damage, aware that long-lasting hostility weakens both sides unnecessarily. Others quietly observe tensions from a distance and choose when to intervene, gaining influence, without taking constant risks that could harm them. These behaviors require memory for past interactions stretching back weeks or months. They require the ability to predict how others will respond to actions. They require a sense of how relationships combine to shape group stability overall. In the shifting web of glances, gestures, and coalitions that form and dissolve, an early form of strategic social thinking emerges that foreshadows human negotiations and alliances perfectly. Human intelligence may rise when we engage with ideas just beyond our understanding. When a concept is neither easy nor impossibly difficult, it occupies a sweet spot where your mind must stretch to grasp it. In this zone of challenge, effort feels demanding but not hopeless at all. your brain recruits additional resources, bringing working memory, attention, and reasoning into closer coordination than normal. As it struggles to follow the new idea, it forges connections between existing knowledge and the unfamiliar structure in front of you. Each partial success reinforces motivation to continue. Each partial failure reveals gaps that can be bridged with further exploration and effort. Over time, repeated engagement with material just beyond current ability expands your capacity to think. People who seek out such challenges in art, science, philosophy, or everyday problem solving gradually build more complex mental frameworks that change how they see everything. Intelligence doesn't grow from remaining inside what is already known and comfortable. It grows from reaching into the near unknown and pulling pieces of it back into understanding bit by bit. Each challenge stretches the mind's capacity, creating new pathways and connections that weren't there before. This continuous expansion transforms not just what we know, but how we think about knowing itself. Parrots form concepts about same and different in ways similar to human children developing cognitive abilities. During carefully designed tests conducted over years, some parrots can look at pairs or groups of objects and judge whether they match in color, shape, or number, even when the specific items are completely new to them. They're not simply memorizing correct responses for familiar combinations they've seen before. They're applying abstract rules about sameness and difference that hold across many different situations and contexts. When presented with a fresh set of objects they've never encountered, they can still indicate which ones share a property and which ones don't, showing clearly that they understand a general idea rather than a single example. This ability represents genuine conceptual thinking, not mere pattern recognition. Human children pass through a similar stage as they learn to classify and compare objects in their world. Parrots reach this ability through entirely different evolutionary paths millions of years apart, using vocal learning, social intelligence, and a powerful curiosity about their surroundings. Their minds reveal that the capacity for abstract comparison isn't limited to primates at all, and that the roots of concept formation can appear in feathered brains just as well. Neural networks in animals sometimes store long-term memory in their immune systems in truly strange and unexpected ways. In some organisms, the cells that defend the body against disease also carry traces of past experiences that reach beyond just pathogens and infections. Immune cells adapt to repeated exposure over time, and their adaptations can influence how the nervous system responds to stress, trauma, or recurring events in ways scientists are only beginning to understand. Over years, patterns of immune activity shape the body's baseline state, altering the chemistry in which neurons operate day to day. This creates a subtle record of what an animal has lived through, written not only in synapses and connections, but in circulating cells and signaling molecules flowing through blood. The body becomes a living archive of experience, storing memories in places we never thought to look. In certain cases, these immune patterns can even affect offspring, who inherit a body already tuned by the experiences of previous generations before them. Memory spreads from brain to blood, from individual life into lineage across time. The experiences of one generation literally reshape the biological inheritance of the next, creating a bridge between past and future written in cellular language. Let yourself rest now. Let these ideas drift through your mind like gentle currents. There's no need to hold on to anything. Just let it all wash over you as you sink deeper into comfort and ease. The quiet world of intelligence. Let's take a slow walk together through the softest corners of awareness. Settle in, get comfortable. Let your breathing find its own gentle rhythm as we explore something beautiful tonight. You know, intelligence isn't what we once thought it was. It's not just trapped inside neurons firing in a brain. No, it spreads through the whole body, the whole being. Every organism learns from the world in its own way. When you reach for something, when you sense danger, when you feel joy rising in your chest, that's intelligence moving through you like water finding its path. It flows through every cell, every sensation, every moment of being alive. Think about your own choices for a moment. When you decide something, when you feel that moment of choosing, it feels so clear, doesn't it? like you're the author of that decision. But here's the beautiful secret. Your brain has already been working for you quietly beneath the surface of your awareness. Before you even felt yourself deciding, sensory systems were already gathering whispers of information from the world. Emotional centers deep in your mind were weighing what matters to you. Motor planning regions were already beginning to lean toward one action over another. All of this happens in the hidden machinery of your mind, preparing the stage for what you'll experience as choice. These processes happen so fast. They unfold in the hidden spaces of your mind, largely without you noticing. And only when they reach a certain point, a certain threshold, does your conscious mind step into the story. Awareness arrives like someone walking into a play that's already begun. You narrate what's happening. Sometimes you adjust the ending, but you never start from nothing. You're joining a performance your brain began without asking permission. This doesn't make your choices less real. It doesn't diminish the beauty of deciding. Instead, it shows you something profound. Your conscious will is just one part of a much larger system. Reflexes live there. Habits nest in those depths. Deep evaluations you've gathered over a lifetime all contribute to who you are. The feeling of deciding is simply the moment when all that hidden activity becomes visible to itself. And in that visibility, in that precious moment of awareness, new possibilities for reflection and change can finally appear. The language of the earth. Now let's drift somewhere else. Imagine the wide open savannas of Africa. Picture elephants moving across that vast landscape, their massive bodies swaying with each step. You might think they stay connected through sight and sound, but there's another channel, something more subtle, more ancient, a conversation happening beneath your feet. Elephants coordinate their movements through vibrations that travel through the ground itself. As the herd moves, elephants send signals that don't only float through the air. They create low-frequency rumbles and stomps that pass through soil and rock. These vibrations ripple outward through the earth like invisible messages, carrying information across distances that would make vocal communication impossible. And here's where it gets magical. Elephants have sensitive receptors in their feet and trunks. They can detect these tremors, these whispers in the ground. They can sense the distant movements of companions who are completely out of sight, maybe miles away. Through this hidden channel, they coordinate group travel. They warn each other of danger. They guide stragglers back to the herd, all without needing to see each other. The earth itself becomes their telephone line, their internet, their shared consciousness. Young elephants learn this language by following the older members. They feel the faint messages underfoot. They learn to read the earth like we learn to read books, slowly discovering meaning in what once seemed like random sensation. Over long distances, this vibrational communication knits the entire herd into something greater than its parts, a coherent unit. Even when members scatter across the landscape, the ground itself becomes a medium for shared awareness. Information travels between these massive bodies, and they move like a single living network across the land, connected by invisible threads of vibration and understanding. The dance of creation. Let's turn inward now, back to the human mind. Your creativity, that spark that makes you uniquely you, may depend on brain regions that compete and cooperate at the exact same time. Isn't that fascinating? Inside your brain, some networks specialize in focus and control, in goal-directed behavior. They keep you on track, but other networks favor imagination. They love wandering thought and free association. They want to explore without rules. And somehow, these opposing forces create magic together. During creative work, these networks don't take polite turns. They engage in a delicate tension, a kind of dance. The imaginative systems generate possibilities without worrying about whether they make sense. They throw ideas into the air like confetti. Meanwhile, the controlling systems evaluate, refine, and select among those wild ideas. They're the editors, the sculptors, shaping raw possibility into something meaningful. Sometimes these networks oppose each other. Discipline tries to suppress ideas that seem too strange. Daydreaming resists all that constraint. But when creativity really flows, when you feel that magical state, they achieve a dynamic balance. The open networks roam widely, but they stay tethered to some sense of purpose. The controlling networks relax just enough to allow novelty to bloom, but not so much that your thoughts dissolve into complete chaos. It's like jazz music, where structure and improvisation blend into something neither could achieve alone. This ongoing dance between cooperation and competition gives creative thinking both its structure and its vitality. It allows new forms to appear without losing coherence, without falling apart into nonsense. The most beautiful ideas emerge from this tension, born from the friction between freedom and form, between wildness and wisdom. Memories beneath the waves. Now let's descend beneath the waves, into the shifting underwater landscapes where the scenery changes with every tide. Here live the cuttlefish. These remarkable creatures carry a form of memory that's astonishing when you really think about it. In their alien bodies, behind those strange horizontal pupils, lies a mind capable of something we thought belonged only to more advanced species. Cuttlefish remember specific events in a way that resembles what we call episodic memory. They retain detailed recollections of places they've explored. They can distinguish between areas that offered rich prey and those that presented danger. But their memory includes more than just locations. It includes the circumstances of each experience, the time of day, the quality of light filtering down through the water, the feel of the current. They remember not just where, but when and how, creating rich narratives of their underwater experiences. This ability to recall specific episodes from their past allows cuttlefish to make sophisticated decisions about where to hunt and when to rest. They can anticipate patterns in their environment based on previous encounters, adjusting their behavior to match the rhythm of the ocean around them. Their memories are flexible, context-dependent, and remarkably detailed for creatures with such different brains from our own. In the quiet depths, these masters of camouflage carry libraries of experience, each memory a chapter in their ongoing story of survival and adaptation. When a cuttlefish returns to a familiar reef or sandbank, it behaves as though it's consulting an inner timeline. It adjusts its actions based on a combination of where it is and what happened there before. This memory doesn't operate like a simple photo album. It functions as a flowing record of experiences stitched together across time. This helps them predict things, which hiding places might still be safe, which hunting areas are likely to have replenished with food, which predators might still be lurking nearby. Even as cuttlefish age, they maintain this capacity with surprising clarity. They show a preservation of memory rarely witnessed in other ocean dwellers. Their intelligence emerges through a beautiful fusion of perception, recollection, and anticipation. It allows them to move through their complex territory with a confidence shaped by lived experience. Let's come back to your own experience for a moment. Tonight, as you rest, your brain will do something extraordinary. It will use sleep to strengthen hidden patterns you didn't even notice you learned today. Throughout each day, your brain absorbs countless fragments of information that drift beneath conscious awareness. Words you overheard in passing, patterns you glimpsed without really looking, rhythms you sensed during movement, subtle shifts in tone or expression from people around you. All of these settle quietly into your neural circuits like snow falling on a field. When sleep arrives, these fragments awaken within the intricate waves of your nocturnal brain activity. During the lighter stages of rest, your networks replay traces of your waking experience. It's as if your brain is sorting through memories it gathered earlier, deciding what matters. As the night deepens, as you sink further into sleep, your brain begins reinforcing the patterns it deems valuable. It links them with related impressions. Slowly, it weaves them into more stable forms. This process strengthens learning that felt vague during the day. It turns faint impressions into accessible knowledge. People often wake with improved understanding of concepts that resisted them the day before. Musicians find that difficult passages have somehow become easier overnight. Language learners speak with smoother rhythm. Problem solvers discover clarity where confusion once reigned. Sleep serves as an unseen teacher, shaping your cognitive growth in the hidden hours when awareness fades and your internal rhythms carry your mind toward deeper integration. Let's travel now to sandy plains beneath clear tropical waters. Here, certain fish create something that will take your breath away. They build intricate structures that reveal an understanding of geometry. These fish create astonishing circular formations composed of ridges and valleys shaped with steady precision. The structures span impressive distances and require sustained effort to maintain. The fish sweep the sand with repetitive motions, adjusting the depth of grooves. They carefully manage symmetry with an attention to detail that seems almost impossible. They orient their bodies in deliberate arcs. They return again and again to refine small sections until the entire formation reaches an elegant balance. Although driven by instinct, these creatures exhibit an awareness of spatial relationships. They monitor angles, they align contours, they correct disturbances caused by waves or drifting sand. The final structure resembles an underwater mandala. It functions both as a display for potential mates and as a demonstration of refined motor intelligence. Think about what this requires. The fish must hold a blueprint in memory throughout the entire construction process. It must maintain consistent spacing. It must adjust each segment in response to changing currents. Their artwork vanishes with time, swept away by the ocean, but its creation reveals a remarkable ability to manipulate geometry through motion alone, through nothing but the movement of their bodies and their persistence. Your own intelligence, your human mind, emerges from interactions between many tiny brain networks. Let that sink in for a moment. Within your brain right now, countless miniature networks are operating simultaneously. Each one performs a different task. Some monitor sounds and shapes around you. Others store fleeting impressions for use in your very next thought. Still others evaluate emotion, manage planning, construct language, or connect what you're experiencing right now with memories from years ago. No single network carries the full weight of your intelligence. Instead, thought emerges from the shifting alliances formed between these circuits. During moments of reflection like this one, they coordinate their rhythms. They exchange signals that travel through intricate pathways you'll never consciously perceive. When a challenge arises, networks that typically work separately may suddenly join forces. They create a temporary union that produces a novel insight. Once the challenge passes, the networks dissolve back into their usual patterns. This constant formation and reformation of alliances allows your mind to adapt to changing environments with remarkable speed. Your intelligence lives not in isolation. It lives in the harmony created by countless contributors working in dynamic balance, all cooperating to make you who you are in this moment. In forests around the world, certain birds are practicing songs right now in their sleep. Young birds learning to sing spend their daylight hours absorbing the melodies of adults. These melodies hold deep social significance. They mark territory. They announce identity. They carry the unique signature of each species. As night falls and the forest grows quiet, you might think the learning stops, but it doesn't. Within the sleeping bird, neural circuits governing vocalization replay fragments of the day's songs. These internal echoes occur without any physical movement, yet they activate the same sequences that control real singing. Through these nocturnal rehearsals, the bird adjusts pitch, timing, and rhythm. It's practicing in its dreams, gradually transforming scattered notes into coherent melodies. When dawn arrives and the bird awakens, it has improved command over its voice, shaped by work performed while sleeping. This nightly refinement continues for weeks or even months, depending on how complex the species' song is. By the time the bird finally sings with full confidence at sunrise, the melody it produces carries the imprint of countless silent practices woven through many nights of sleep, just like your brain is working right now while you rest. Here's something that might change how you approach problems tomorrow. Problem solving actually improves when your brain shifts into using energy-efficient states. When you confront a difficult challenge, your mind doesn't always rely on intense effort. In fact, forcing things often makes them harder. Instead, your brain often shifts into a quieter mode, a mode where neural activity becomes more organized and efficient. This mode reduces unnecessary firing. It concentrates resources along the pathways most relevant to the problem you're trying to solve. In this state, information flows with greater clarity. Subtle connections can emerge that would be drowned out during periods of high stress. The mental landscape becomes less cluttered. Ideas that once felt tangled begin to separate into understandable parts. Many breakthroughs occur during moments of calm reflection, rather than forceful thinking. This happens because your brain reaches optimal efficiency when tension relaxes, when you stop trying so hard. This transition into an energy-saving mode allows complex relationships to surface naturally. It reflects a deeper form of intelligence, one that depends on harmony rather than strain. So when you're stuck on something, sometimes the best thing you can do is let go. Step back, breathe, let your brain find its efficient state. Monkeys living in complex social groups have developed a fascinating skill. They infer intentions from gestures in ways that mirror early human cognition. Every monkey in the group observes the others with keen alertness. Every gesture carries possible meaning. A relaxed reach may show peaceful intent. A slight hesitation may reveal uncertainty or nervousness. A tightening of posture may signal an approaching challenge or conflict. Through constant exposure to such cues, monkeys develop a capacity to interpret the motives behind actions. They adjust their own responses based on these interpretations. They choose when to support an ally, when to avoid a potential dispute, when to initiate cooperation. This ability parallels how young human children learn. Children also learn to read intention from motion rather than from explicit instruction. Nobody teaches them. They simply watch and learn. For monkeys, this skill strengthens group cohesion. It allows smoother interaction within environments where misunderstanding could lead to serious conflict. Their perceptive intelligence emerges naturally from lives filled with observation, adaptation, and subtle interpretation. Something beautiful can happen during deep conversation between people. In certain moments of shared dialogue, two minds fall into an unusual form of harmony. As attention intensifies and emotion aligns, brain rhythms in both individuals begin to follow compatible patterns. This synchrony reflects more than simple agreement. It arises from simultaneous engagement with the same idea. It forms a temporary shared mental landscape. During these moments, communication becomes fluid and effortless. It's as though each person understands the other with heightened clarity, almost before words are spoken. The alignment strengthens when trust deepens, or when the conversation touches on deeply meaningful subjects. Although brief, these periods of synchrony reveal the profoundly social nature of human cognition. They show how thought can stretch beyond individual boundaries, how it can form a bridge between minds through the simple act of genuine connection. Young wolves grow up immersed in the shifting tensions of pack life. They learn social rules by watching conflicts inside the pack. They observe quarrels over food, over rank, over territory with unwavering attention. Each conflict teaches a different lesson. They learn who commands respect and who yields gracefully, how disputes can resolve without lasting resentment. They note the postures that signal challenge, the gestures that restore peace, the precise timing that determines whether an interaction escalates into violence or dissolves into reconciliation. Through these observations, wolves build a mental framework for navigating their own future roles. They eventually adopt behaviors that maintain harmony, reduce unnecessary violence, and strengthen group unity. Their understanding of social balance emerges gradually, shaped by countless moments of watching, learning, and absorbing the unwritten rules that govern pack stability. Your own judgment uses mental shortcuts that often reveal hidden patterns in your environment. Throughout your life, your brain has learned to recognize subtle regularities in the world. It stores these regularities as rapid-acting mental shortcuts that guide your decisions with impressive speed. A slight shift in someone's tone may signal emotional change. A faint environmental cue may reveal a hidden pattern. A familiar structure in a new situation may suggest a likely outcome. These shortcuts don't reflect carelessness. They reflect deep familiarity with repeated experiences. Although they occasionally mislead you, they function remarkably well in environments that mirror the conditions in which they were learned. They allow you to act quickly in complex situations where full analysis would be far too slow. These patterns reveal how intelligence extends beyond deliberate thought. They rely on quiet forms of knowledge you've accumulated through years of simply living and paying attention. In certain dry landscapes, a few remarkable birds have learned something extraordinary. They use tools to manipulate fire in a way that suggests true causal understanding. When flames sweep through tall grass, these birds wait at the edges for fleeing insects, but their intelligence extends far beyond opportunistic feeding. Sometimes they pick up burning sticks, they carry them to unburned patches of land, and then they drop them deliberately into dry brush. The resulting flare sends insects scattering, creating new hunting grounds right before their eyes. For this behavior to work, the bird must predict that a burning fragment will ignite fresh fuel, that flames will move across the grass, that prey will flee as the fire spreads. It must also handle the ember with care to avoid injury while still placing it where ignition is most likely. This suggests an understanding of cause and effect strong enough to model how fire behaves. Such knowledge cannot rely on pure instinct because the technique must change depending on wind, fuel, and temperature. It's learned through experience, through memory, through experimentation with a dangerous element that reshapes the environment itself. Your intelligence may increase when you form mental models of entire systems. When people try to understand only isolated details, their thinking remains narrow. But when they begin constructing mental representations of entire interacting systems, their intelligence expands dramatically in both reach and depth. A system can be a forest with all its interconnected life, a community with all its relationships, a scientific principle with all its applications, even the internal workings of a complex machine. To build such a model, your brain must track relationships among many moving parts. You must anticipate how changes ripple through the structure. You must adjust predictions as new information arrives. This process strengthens areas of your brain involved in reasoning, working memory, and abstraction. It also encourages more flexible thinking because systems rarely behave in simple linear ways. People who habitually form broad mental models grow better at planning, at innovation, at adaptation. They detect patterns hidden in complexity. They foresee outcomes that escape minds focused only on fragments. By holding entire structures in mind, they allow intelligence to operate across layers of reality rather than getting stuck at a single point. Within many primate groups, individuals demonstrate a sophisticated understanding of reciprocity. They track social debts over years. They remember who offered support, who shared food, who withheld help during critical moments. These memories shape long-lasting social strategies. A primate that receives grooming during a time of hardship may later assist that benefactor during a territorial dispute months down the line. Another that was ignored in a moment of need may quietly withhold support when the neglectful companion seeks help. These exchanges don't unfold through immediate trade. They happen through long-term tracking of relationships. Individuals monitor fairness. They remember past interactions. They adjust their behavior accordingly over time. This form of reciprocity requires judgment, memory, and the ability to connect past behavior with future decisions. It also requires restraint because the benefits of maintaining social bonds extend far beyond a single encounter. Over years, these remembered debts form the foundation of alliances, peacekeeping, and stability within the entire group. The intelligence behind these exchanges shows that primates perceive social life as an intricate web of obligations that must be honored to preserve harmony. Here's something important about your own memory. Human memory strengthens dramatically when you connect new knowledge to personal meaning. Your mind doesn't store all information with equal weight. Facts learned without context often fade quickly. They slip from awareness as easily as they entered. But when new knowledge resonates with your personal experience or emotion, memory deepens in a profound way. Your brain binds the fresh information to existing networks of significance. It weaves the new knowledge into the very fabric of your identity. This connection activates areas involved in emotion, narrative, and long-term storage. It anchors the material much more firmly. Students who link scientific ideas to their personal curiosity retain them far longer. Readers who relate characters to their own feelings remember stories vividly for years. Anyone who ties abstract lessons to lived experience strengthens retention almost automatically. Meaning becomes the thread that stitches knowledge into lasting form. When your mind incorporates information into its sense of self, memory transforms from passive storage into active integration. Far from shore, certain sharks travel across vast open water with astonishing accuracy. They often return to the exact same feeding or breeding grounds year after year. They achieve this navigation through sensitivity to Earth's magnetic field. Their bodies contain specialized cells capable of detecting subtle shifts in magnetic intensity and orientation. As they swim through the deep ocean, they gather information about the magnetic signature of each region. Gradually, they build an internal representation of the world beneath the waves. This magnetic sense functions like a natural compass layered upon a global map. When currents change or storms disturb familiar routes, the sharks still locate their destinations. They do this by referencing the unseen structure of the planet itself. This ability requires more than instinct because magnetic fields vary with depth, location, and time. The sharks interpret these variations. They update their internal maps. They adjust their course accordingly. Through this remarkable capability, they navigate an environment with absolutely no visible landmarks. They're guided by an ancient intelligence attuned to the very fabric of the earth. When you're working on something difficult, your insight often accelerates when you allow mental rest between challenging ideas. During demanding thought, your mind often reaches a point where further effort produces only confusion. Everything gets tangled, nothing makes sense. Yet when you step back, when you rest or shift focus, insight frequently appears with unexpected clarity. This occurs because rest allows your brain to reorganize information without conscious pressure. Neural networks that were overloaded during intense concentration begin to settle into more coherent patterns. Hidden relationships among ideas strengthen during this rest. Irrelevant noise fades away. As your mind relaxes, fragments of understanding drift into new configurations. They form structures that were completely inaccessible during strain. This explains why breakthroughs so often happen during walks, during quiet moments, during gentle routines rather than at the height of maximum effort. Rest isn't the absence of thinking. It's the space in which deeper connections form beyond your deliberate awareness. In this softened state, insight arrives naturally. It rises from the quiet depths of your mind like a bubble surfacing in still water. In dense rainforests, orangutans face challenges that demand more than instinctive responses. They use improvised solutions that reveal flexible foresight. They often encounter situations involving obstacles, hidden food, or resources that seem unreachable. Instead of relying solely on learned routines, they improvise with remarkable creativity. An orangutan may choose a branch of a particular thickness to test the stability of a crossing. It may strip leaves from a twig to create a precise tool for extracting insects or sap. In some cases, it combines several objects to achieve a specific goal. This demonstrates an ability to imagine a future outcome and plan systematically toward it. This foresight reflects a sophisticated understanding of cause and effect. Orangutans also adapt their strategies when circumstances change. If a tool breaks, they select a better one without frustration. If the environment shifts, they modify their approach. Their improvisation arises from careful observation, from memory, and from a flexible intelligence shaped by the incredible complexities of forest life. Your own creativity and insight flourish when your mind holds many different kinds of knowledge at once. When ideas from completely unrelated fields collide inside your head, they generate combinations that would never arise from a single discipline. A person who understands both art and mathematics may discover patterns invisible to someone focused on only one. Someone familiar with both storytelling and engineering may find solutions that blend imagination with structure in unexpected ways. Within your mind, these different domains mingle. They compare, they merge and reshape one another. This interaction strengthens cognitive flexibility. It broadens perspective. It encourages novel thinking in ways that specialization alone never could. Diversity of thought becomes a catalyst for innovation because it allows your mind to draw connections across distant regions of understanding. The more varied your internal landscape, the more paths exist for intelligence to travel through your thoughts. In controlled experiments, pigeons demonstrate abilities that challenge fundamental assumptions about cognitive complexity. They learn abstract rules that scientists once thought required large brains. They learn to categorize objects not by memorizing individual examples, but by identifying general principles that apply across many variations. They can distinguish patterns involving relative size, shape, or brightness, even when the specific items change every single time. These tests reveal that pigeons grasp abstract concepts. They apply rules flexibly rather than relying on simple repetition. Their performance shows that intelligence doesn't depend solely on brain size. It depends on the organization of neural circuits. The pigeon brain processes visual information with remarkable efficiency. This allows these birds to understand relationships among objects that appear completely different on the surface. This insight forces scientists to reconsider how widespread abstract reasoning may actually be throughout the natural world. Human intelligence develops within a cultural environment that transmits knowledge across generations at speeds far surpassing biological evolution. Your mind evolves through culture, which changes faster than genetics ever could. Every individual inherits not only a body shaped by ancestry, but an entire world filled with stories, tools, symbols, and practices created by countless others who came before. Culture acts as an external memory that extends far beyond the capacity of any isolated mind. As people learn from one another, they refine ideas, they expand skills, they deepen collective understanding. Cultural evolution allows innovations to spread rapidly, accumulating layer upon layer of shared insight. While genetic changes require vast stretches of time spanning thousands or millions of years, cultural knowledge can transform within a single lifetime, within a single generation. This rapid exchange shapes how humans think, how they solve problems, how they imagine possibilities. Your intelligence becomes a product of collaboration across centuries. It's woven from the contributions of many minds acting together over time. You carry within you the wisdom of people you'll never meet from eras you'll never experience. Long before a child understands the meaning of a single word, their brain is already absorbing something crucial. The brain learns language by detecting tiny patterns in streams of sound. As speech washes over the senses, the brain begins identifying repeating fragments. It notices which sounds tend to appear together and which rarely do. This process unfolds automatically, without any conscious effort. It reveals an extraordinary ability to extract structure from complexity. Even in noisy environments, the brain isolates syllables and probabilities. It gradually carves boundaries between words that were never presented as separate units. Infants exposed to multiple languages simultaneously keep these patterns distinct. This shows that the mind can track several different sound systems at once. As learning continues, the brain strengthens connections that represent useful regularities. It prunes those that don't. Meaning gets layered onto this scaffolding later, built upon an underlying architecture formed through the recognition of subtle acoustic patterns. Language learning, therefore, begins not with vocabulary, but with pattern detection, so fine-tuned that it can transform unbroken sound into a complete map of communication. When researchers train advanced learning systems to solve complex tasks, something fascinating happens. Artificial neural networks discover surprising strategies that mirror biological intelligence. These artificial networks often develop solutions no one anticipated. They reorganize information. They build internal representations. Sometimes they discover shortcuts that resemble strategies found in nature without being instructed to do so. They cluster similar concepts together. They compress data into meaningful structures. They form layers of abstraction that help them navigate new situations. In some cases, their internal workings echo patterns seen in animal brains: sparse coding, modular organization, gradual refinement of internal models. These parallels emerge because both artificial and biological systems face similar fundamental challenges when interpreting the world. Each must filter noise, each must detect relevant structure, each must form stable predictions. Artificial networks achieve this through vast numbers of simple units working together. Biological networks rely on neurons shaped by millions of years of evolution. The similarities suggest that intelligence may follow certain universal principles, that whenever a system must learn from experience, certain patterns emerge. It doesn't matter whether that system is made of silicon or living cells. In dense vegetation where sound and scent easily scatter, certain insects have evolved a remarkable form of communication. They use vibrations in plant stems as a covert communication system. Instead of calling through the air where predators might hear, they create faint pulses that travel along stems and leaves. These vibrations carry crucial information about danger, about location, about readiness to mate. Because the signals move through solid material, they're far less likely to be detected by predators listening in the air. Each species shapes its vibrations with specific rhythms and intensities. They form an intricate language that others of the same kind can decode instantly. Some insects even adjust their signals based on wind conditions or plant stiffness. This shows a flexible awareness of how physical environments shape communication. Researchers studying these systems discover layers of complexity hidden beneath what appears at first glance to be completely silent foliage. This covert communication reveals that intelligence can thrive even in tiny bodies when evolution supplies subtle channels for transmitting knowledge. Your thinking improves in a special way when you explore questions with no clear answers. When you confront uncertainty, your mind stretches beyond routine patterns. Wrestling with questions that resist simple solutions forces your brain to experiment with new connections, to explore unfamiliar perspectives. Instead of relying on well-worn pathways, cognition shifts into a more flexible mode. Creativity and insight become more accessible. This process encourages tolerance for ambiguity. It strengthens reasoning. It deepens curiosity. Even when no final answer emerges, the act of exploring the unknown expands your mental landscape. Such questions invite reflection and imagination. They invite the kind of cognitive wandering that supports innovation. They teach your mind to remain open, to consider multiple possibilities, to recognize that understanding often grows from the search itself rather than the destination. By engaging with uncertainty, your intelligence becomes more adaptive, more resilient, more capable of uncovering hidden layers of meaning. Across various habitats, primates demonstrate a sophisticated grasp of how objects interact with the world. They modify tools in ways that show a deep understanding of causality. When faced with obstacles that block access to food, they select sticks, stones, or leaves. Then they reshape them to improve their effectiveness. A primate may shorten a branch for better control. It may sharpen one end to extract insects more efficiently. It may adjust the thickness to increase strength. These modifications reveal an ability to predict how altering a tool will change the outcome of the task. The behavior requires foresight. It requires experimentation and memory of past successes. It also reflects an understanding that tools can act as extensions of the body, that they serve as intermediaries between intention and environment. When primates refine these tools, they show more than simple trial and error. They reveal causal reasoning grounded in observation and guided by genuine insight into how the physical world works. While individuals can achieve remarkable feats of insight, collaboration unlocks forms of intelligence that simply don't appear in isolation. Human intelligence often peaks when we collaborate rather than compete. When people share ideas, critique assumptions, and build upon each other's thoughts, they create an environment where cognitive strengths combine in powerful ways. One person may notice a pattern another completely overlooked. Someone else may reframe the problem in a way that suddenly clarifies its entire structure. Through conversation and joint exploration, a group can develop solutions no single member would have reached alone. This form of collective intelligence thrives on communication, on empathy, on the willingness to integrate diverse perspectives. It also reflects humanity's deep evolutionary history. Cooperation supported survival and shaped the development of complex thought. When minds work together, they create a whole greater than the sum of its parts. This reveals that intelligence isn't merely an individual trait, it's a shared capacity that flourishes through connection. In the vastness of the open sea, some whale species produce intricate songs that travel for enormous distances. These melodies aren't fixed. They change through time as individuals introduce new phrases, new rhythms, new structures. Other whales adopt these modifications, gradually transforming the song into a shared cultural creation. As migrations bring distant populations into contact, the updated versions spread across thousands of miles. Eventually, entire regions share a single evolving composition. This cultural transmission requires memory. It requires imitation and sensitivity to subtle acoustic detail. It also reveals a social intelligence capable of maintaining traditions across enormous distances. Whale song becomes a living artifact shaped by collective creativity. It reflects the dynamic interplay between communication, learning, and social bonding in the ocean's hidden world. Songs that drift through the deep water carrying meaning across generations. Your mind responds to surroundings with surprising sensitivity. Humans think more deeply when surrounded by environments that encourage reflection. Natural landscapes, quiet spaces, and environments with gentle sensory input often support deeper thought. In such places, mental noise decreases. This allows attention to settle. Ideas unfold with greater clarity. Reflection becomes easier when your senses aren't overwhelmed. This gives your brain room to process complex information. These environments help you step back from immediate concerns. They help you consider broader perspectives. They also allow memories and insights to surface that might remain buried in more chaotic settings. Whether you're walking among trees, sitting near water, or simply resting in a calm room, you often access richer forms of thought when the world around you becomes quieter. The setting acts as a cognitive partner, guiding your mind toward careful observation and deeper awareness. Some species display primitive forms of numerical awareness. They show early signs of counting through subtle neural responses, even without language or formal symbols. They show distinct neural activity when the number of objects in their environment changes unexpectedly. These patterns appear even in very young individuals. This suggests that sensitivity to quantity emerges naturally rather than through training. Animals may use this awareness to judge group size, to identify potential threats, or to choose the most advantageous feeding site. The neural signatures reveal that their brains treat numerical changes as meaningful events. They respond differently to increases, to decreases, to stable quantities. While far simpler than human mathematics, this early numerical sense provides a foundation for more complex reasoning. It also shows that intelligence can arise through basic cognitive building blocks that evolved long before symbolic thought emerged. As technology becomes woven into daily life, something profound is happening. Human intelligence may be expanding as we integrate with the machines we create. Your cognition evolves alongside technology. People extend memory through digital storage. They amplify pattern recognition through analytical tools. They explore ideas with computational assistance. These machines don't replace thought. They expand its reach. They transform how humans learn, how they create, how they understand the world. Interacting with technology encourages new forms of problem solving, forms that blend biological intuition with artificial precision. It also reshapes communication, collaboration, and the pace at which knowledge grows. Over time, this partnership between human and machine forms a hybrid intelligence capable of insights neither could achieve alone. The merging isn't physical, it's cognitive. It's built through constant exchange between organic minds and the tools they design. As this integration deepens, your intelligence stretches into new territories. It reflects an ever-expanding interplay between creativity and invention. And now, as we drift toward the end of this quiet journey through the many shapes of intelligence, allow yourself to feel the soft settling of your mind. You've traveled across oceans tonight, through forests and sky. You've wandered through hidden networks of thought within the brain, through delicate moments of insight within the natural world. You've followed sparks of understanding as they moved between animals, between cultures, between machines and memories. Now everything begins to slow down, the pace softens, the journey comes to rest. Simply breathe now, let your shoulders fall away from your ears. Let your attention soften like light through morning mist. Let the ideas you met tonight fade into a warm glow at the edges of your awareness. You don't need to hold any of it. You don't need to remember or analyze. You can simply let go. The night is here to cradle you now. Your mind has done enough work for today. It's carried you through so much. Settle into the quiet. Feel the weight of your body supported completely. The darkness is gentle. The silence is kind. Everything you needed to learn has already been absorbed somewhere deep inside. Now there's nothing left to do but rest. Good night. Sleep well. Let yourself drift into the peaceful depths where all these ideas will weave themselves into dreams.